Welcome to Algebra 2C. We are now working on the Semester 2 Final Exam Review, Chapter 7 and 8. Okay, I'm going to start with problem number 4 in Chapter 7. Notice how we are multiplying these two expressions together. And when you do that, when we multiply the two, we have to add the exponents. And I can only add the exponents if they have the same base. So a to the 1/3 times a to the 2/3, we add those exponents, which gives us a to the 3/3. And the same idea with the b. B to the 1/2 times b to the -1, which gives me b to the -1/2. And now let's simplify this. Well, a to the 3/3 is just a to the first. And remember, to get rid of a negative exponent, you have to flip it and put it in the denominator. So that's our final answer. Let's go down to the next one. Number 7. Okay, this negative sign confuses a lot of people, but it's outside of the square root. So what I'm going to do is I'm just going to keep it on the outside, but then break this off into 3 easier pieces. Because remember, if they're being multiplied by each other, we can just break it off separately and take the square root of each individual term. So now the square root of 49 is just 7. How many times does 2 go into 6? Because the square root is actually like this invisible 2 right here. So how many times does 2 go in 6? It goes in 3 times. And then how many times does 2 go into 16? Well, it goes in 8 times. So that's my final answer. Let's go down to 15. 15 is a little more tricky. Okay, so here's what we need to do. We need to simplify these expressions in the square root first, and then we can start seeing if we can combine like terms. So I'm just going to bring down this 2x, and now I'm going to break this off individually. Square root of 12, square root of x, square root of y squared, minus, bring down that y, square root of 75, square root of x cubed. So let's break down the square root of 12. Well, the square root of 12 can break down into 4 times square root of 3, and square root of 4 is just 2. So right now I have 2x times that square root of 4, which is 2, square root of 3. The square root of x cannot simplify anymore. But how many times does 2 go into 2? Well, it goes in 1, so I can simplify that just to y to the first power. Okay, let's look at the square root of 75. Well, think about any perfect squares that fit into 75. Well, that's got to be 25 and 3. And the square root of 25 is just 5. So I'm going to bring down that y, multiply it by 5 root 3. And then how many times does 2 go into 3? Well, it goes into once, and there's a remainder of 1. So now what I'm going to do is I'm going to group everything that's not underneath the square root, bring it out front in both individual terms. So I have 2 times 2 right here, which is this 4. I have an x and a y not underneath it. And left underneath the square root, I have a 3x. Over here, I have that 5 out front. I have an x and a y. And then underneath, I have a 3x. So here's what you need to look for. The only way they're going to be like terms is they have the exact same variables and the exact same variables and numbers underneath the square root, which they do. So we have 4 of them, and we subtract 5 of them, which gives us a -1 xy to the 3 square root of 3x. So that's a tricky one, but remember, you got to figure out what is like terms and what is not. Okay, number 17, multiplication. The easiest way to do multiplication is just multiply them together first, and then break it off. So I'm going to multiply 14 times 28, which gives me 392. X squared times x, so you add the exponents, which is x to the 3rd. And then y to the 5th times y to the 3rd, add the exponents, so it's y to the 8th. And now what I can do is I can just simplify in each individual part separately. Square root of 392, square root of x cubed, square root of y to the 8th. So 392 is a tricky one, but in fact there's a big perfect square that fits into it. That's going to be 196 and 2. So the square root of 196 is just 14. How many times does 2 go into 3? It goes in once with a remainder of 1. And how many times does 2 go into 8? Well, it goes in 4 times. So I'm going to bring everything out front that's not underneath the square root. And everything left is going to be underneath that square root. So when we're doing multiplication, please combine them first. Okay, let's flip over. We are looking at, now we're just looking at 18. So 18 is on that bottom right of that page. Multiplication here. A lot of people just multiply the first times the first and the last times the last. We have to distribute, guys. Okay, it's a binomial times a binomial. The square root of x times the square root of x is just x. And now we distribute that, so we get 5 times the square root of x minus 2 times the square root of x, and then minus 10. So let's combine like terms. The only like terms that I see are right here because they're both have the square root of x. So now I get x plus 3 times the square root of x minus 10. And there's no more like terms, so that's our final answer. Okay, let's flip over and look at number 29. Okay, 29, I think you'll refresh your brain and you'll see that it's pretty simple. I need to distribute the 4 first, so I get 8 minus 12i. And now I'm going to distribute this negative sign, this negative 1, because remember there's an imaginary 1 there. So I get negative 4 minus I. That's the key there. And now I'm just going to combine like terms. 8 minus 4, the real part and the real part. And I'm going to combine the imaginary and the imaginary. So 8 minus 4 is 4, and negative 12 minus negative or minus 1 is negative 13i. And that's our final answer. Go down to 33. Okay, 33, we now have a square root in the denominator, so we need to rationalize this. I need to get the square root out of the denominator. So what I'm going to do is I'm going to multiply by the square root of 3 plus 2, square root of 3 plus 2. Because remember, what you do to the bottom, you have to do to the top, because I only want to multiply by a form of 1. It's got to be the same thing in the numerator as it was in the denominator. And now I'm just going to distribute. Okay, multiply these two binomials in the denominator and distribute this 2 in the numerator. So 2 times root 3 plus 2 times 2, which is just 4. In the denominator, square root of 3 times square root of 3 is just 3. Square root of 3 times 2 is 2 square root of 3 minus 2 square root of 3, and then minus 4. So what you'll see is these middle terms, by multiplying by the conjugate, these middle terms will eliminate each other. 2 root 3 minus 2 root 3 is just 0. So that simplifies, so I get 2 root 3 plus 4 in the numerator over 3 minus 4, which is negative 1. So if I want to write that, I can distribute the negative 1 to both terms. So I get negative 2 root 3 minus 4, and that's my final answer. Okay, so let's move on. 37. 37 looks like a tricky one, but notice how they're both being square rooted on both sides. So to undo a square root, what you can do is just square each side. And to square a square root, it's like undoing each other. So we can do that, and we're left with 5x minus 3 equals just 9x minus 7. And now we just solve for x. Okay, so if I solve for x, I get negative 4x over here equals negative 4 over there. And solve for x, I get x equals 1. Okay, let's flip over. Now we're going to look at chapter 8. Okay, chapter 8. This is solving quadratics by a few different ways. We'll do one from each section. Number 4, solving by square roots. So what I need to do is I need to isolate what's being squared. That's how I solve by a square root. So I'm going to subtract 9 first. So I get 3x minus 2 squared equals negative 9. Divide by 3, so I get x minus 2 squared equals negative 3. And then I'm going to square root both sides. If I do that, I have x minus 2 by itself. And remember, the square root of negative 3, only thing we can take out is that negative 1. So I'm going to take out the I, and I'm left with the square root of 3. So I get plus or minus, always two solutions when we square root, like this. Add 2, 2 plus or minus I root 3. Okay? So one key thing to remember is there's always going to be two solutions. Let's go down to number 8. Solve by quadratic formula. So the quadratic formula is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug in we got our a up here, our b, and our c. So let's plug it in. We get opposite of a negative 7 is just a positive 7. Plus or minus negative 7 squared, which is 49. Minus 4 times 1 times 9. All over 2 times 1. Simplify this, I get 7 plus or minus 49 minus 36 is 13. So I get the square root of 13 under there, all over 2. And the square root of 13 is an irrational number, so we cannot simplify that anymore, so we just leave it. Okay, good job. Let's keep moving. Going down to number 10. Solve by completing the square. Okay, you guys got really good at this with circles and parabolas. Same idea. I want to isolate the two x's, so I'm going to bring the 7 to the other side, and I'm going to leave my blank there. So I added 7 to both sides, and now I put a blank in to complete the square. Remember that it's always going to be b over 2 squared to find that missing piece. So if my b is negative 4, then I'm going to put negative 4 over 2 squared. So negative 2 squared is 4. That's what's going to fill my blank. And remember, what I do to one side, I got to do to the other. So I have to put it in both blanks. And now, what we're going to do here is I'm going to factor the left side. X minus 2 quantity squared equals 11. Now square root both sides because we isolated what is being squared. Square root both sides. Remember, that always gives us two solutions. So x minus 2 equals plus or minus square root of 11. Add 2, you get your final answer. 2 plus or minus square root of 11. Okay, that is chapter 7 and 8.